Hi everyone, welcome to a very quick lesson on number systems. So number systems refers to different ways that we classify numbers. I've linked to several videos that cover this, but I'm going to cover it my own way here. So I'll go over this and then I'll use a metaphor of animals. So here you have the real numbers. All of the numbers that we're going to look at in class and that you're going to look at until grade 12 are all real numbers. Unreal numbers are called complex numbers or imaginary numbers. Don't worry about those yet. Now, if a number is real, it could be irrational or it could be part of the rational numbers. Okay? Irrational numbers are numbers that cannot be written as a fraction. The square root of 2 is an irrational number. Pi is an irrational number. These are numbers that have decimal expansions that continue forever and cannot be written as rational numbers that compare integers. Rational numbers are any numbers that can be written as fractions. So this number here, while it's not written as a fraction, could be. We can write that as a fraction. 21.6. Well, that's 21 and 6 over 10. Or 21 and 3 over 5. Or I could do 21 times 5, which would give me 105, and add 3 to that, and that would be 108 over 5. This number is 108 over 5. Okay? It can be written as a fraction. These are the integers. Now, integers are any counting numbers that could be positive or negative. So these are a lot of the numbers that we've been working with this unit, and we take the integers and we put them into fractions, and that makes rational numbers. Now here's an important point. Any integer is also a rational. Notice that this is nested inside this. Okay, so negative 3 can be written as a rational number. Negative 3 over 1. Negative 6 over 2. Negative 9 over 3. Should I continue? Those are all different ways of saying negative 3. So this is an integer, but it's also a rational. The whole numbers and the natural numbers, well, these were our counting numbers that we started with in kindergarten, particularly the natural numbers. The natural numbers are the numbers 1, 2, 3, 4, 5, not including 0, not including negative numbers. The whole numbers, we had 0 only. And then the integers includes all these numbers and adds the negative numbers. The rationals includes all these numbers and adds fractions. And then you have irrational numbers. These cannot be written as fractions. Okay, so let's think about this in terms of animals. Here you have all the animals, all the real animals, okay? No imaginary animals allowed. So there's no unicorns here, but zebras, yes. Now the irrational numbers, we could think of these as humans. Okay, all the humans are over here. And then over here, rational numbers, we could call these all the numbers that are not, all the animals that are not humans. The integers, maybe those are the mammals. And then the whole numbers, that could be the four-legged mammals. And then the natural numbers, these could be, let's say, elephants. All right, so now elephants, they're certainly four-legged animals. They're also mammals, and elephants are also not humans, and they are animals, okay? So notice that if I gave you elephants, you would say, well, it's part of this, 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 and this, okay? Something can belong to many sets, but zebras might be in here. They're four-legged animals, but they're not elephants, so they don't qualify as natural numbers. Okay, now let's take a look at how we're going to test this. I'm going to give you charts that look like this, and you're going to say, well, 3. Well, I know that 3 is part of the natural numbers because it's 1, 2, 3, 4, 5. It's also part of the whole numbers, and it's one of the integers, and I could write that as a rational. Yeah, it's not an irrational because it can be written in a rational way, and it's part of the real numbers. So it's all of those. Negative 7, we didn't learn about that in kindergarten, so it's not natural or whole numbers, but it is an integer. It is a rational, and it is a real number. It's not irrational. 0, well, that only shows up in the whole numbers and the integers. It can be written as a rational, and it is a real number. 3 over 5, this is a fraction. It can only be written as a fraction, or a decimal. Okay, it can't be written as an integer, so it's not that, but it is a rational number, and it is a real number. 0.75 could be written as 75 over 100, or that could be written as 3 times 25 over 4 times 25 And then you would cancel those and you would say, well, that's just 3/4, Mr. Jennings. 0.75 is 75 cents. That's 3/4. So you would say that's a rational number and that's a real number. All right. Now, here are some trickier ones. If I want to trick you, which I do because I want to know who's like getting 100% in this course, it's the people that can't be tricked because they're so solid on the content. Negative 15/3. This is definitely not a natural number, and it's not a whole number because it's negative. It's a rational number, but it is an integer as well, okay, because it's also -5. So it doesn't have to be written as a rational. So yes, it's an integer. It's not irrational, and it is a real number. We didn't see any examples of irrational numbers up there, but here's one. That's an irrational number, but it's also a real number. Okay, pi. If I had pi on the chart, it would also be an irrational real number. 5.4 times 10 to the 2 is a natural number, whole number, integer. It's irrational, it's not irrational, and it's a real number. Why, Mr. Jennings? But there's a decimal there. How dare you tell me that that's a natural number and a whole number? It's not even an integer. There's a decimal. No, watch. 5.4 times 10 to the 2 is scientific notation. With Bedmus, that's equal to 5.4 times 10 times 10. 10 times 10 is 100. 5.4 times 100 is 540. 540 is a natural number, a whole number, and an integer. The square root of 9. Oh, I see that these square root things, they're irrational numbers. Not so fast. Why not so fast, Mr. Jennings? Because I'm tricking you. Here is a square. The square has side length 3. This is a square. Okay, so these are all the same length. That's what this little tick mark means. It means they're all the same length. 3, 3, 3. This is a square. Okay. This box here means a 90-degree angle. So this is a very severe way of saying it's a square. What's the area of this square? Area is length times width. 3 times 3 equals 9. This has an area 9. Okay. So if I asked you what's the square root of 9, well, that would be 3. This is what square root means. It means find me a number that when multiplied by itself gives me the number inside this funky sign. That, my friends, 3 is a natural number, 3 is a whole number, 3 is an integer, 3 is irrational, 3 is not irrational, 3 is real. The square root of -1. What the heck? None of these. That is an imaginary number. And that's all I'm going to say about the square root of -1. You want to know more about that? Do your own research. It's not part of our course. It's super interesting. It's not part of our course. So I wish you well. That's how I would approach these types of questions, and I would have that Venn diagram on my cheat sheet. Bye for now, everybody.